Hi, Mark Donovan here from Falcon Imagery, and today I'm going to show you an easy formula for how to determine top of descent when on a cross-country flight. Often when we're building cross-country flight plans using a nav log sheet, we'll determine our top of descent looking at the Pilot Operating Handbook. However, there's a very simple formula that you can use so that you can calculate your top of descent in the air on a flight. So let's say you didn't build a cross-country flight plan with the nav log, and you're coming into the area of your destination airport. With this very simple formula, you can very quickly determine when you should begin your descent down toward the pattern altitude of that airport. So follow along. To the mountain. Okay, let's get into it. How to easily determine top of descent. All right, simple memory formula to determine top of descent. Assuming 500 feet per minute descent rate and a 90 knot ground speed, which is a common descent rate and ground speed for typical GA plane used in flight training, use the following formula to calculate the start of top of descent to the destination airport. So you take top of descent, it's equal to 3 times the cruise altitude minus the pattern altitude divided by 1,000. So example 1. We have a cruising altitude of 5,500 feet and a pattern altitude of 1,500 feet. This assumes a field elevation of 500 feet. So we take top of descent and we say it's equal to 3 times 5,500 minus 1,500 divided by 1,000, which equals 12 nautical miles. So basically 12 nautical miles away from the airport, we begin our descent from 5,500 down to 1,500 feet. Example 2, cruising at altitude of 8,500 feet to a pattern altitude of 2,000 feet. So again, top of descent is 3 times 8,500 minus 2,000 divided by 1,000 equals 19.5 nautical miles. So again, if we're 8,500 feet and we need to go down to a pattern altitude of 2,000 feet, we're going to need about 19.5 miles to descend to that altitude, assuming the 500 feet per minute descent rate and a 90 knot ground speed. So how do we come up with this basic formula? Well, again, we used here a descent rate of 500 feet per minute, descent rate and a ground speed of 90 knots. Again, we first have to determine the time it takes to descend from a cruising altitude to the pattern altitude. 5,500 feet minus 1,500 feet, that's 4,000 feet. If we descend at 500 feet per minute, we take 4,000 feet divided by 500, and it takes us 8 minutes to descend from 5,500 to 1,500 feet. Next, we need to convert those minutes to hours. So we take 8 minutes times 1 hour per 60 minutes, and we do the math out, and we come up with 0.133 hours to descend that 4,000 feet. Next, we need to determine horizontal distance traveled while descending from the cruise altitude to the pattern altitude using the equation S equals VT, where S is distance, velocity, or V is for velocity or ground speed, and T is for time. So S, or our distance, is equal to 90 nautical miles per hour, that's our ground speed, times that 0.1333 hours to descend 4,000 feet, we come up with 12 nautical miles. So if we want to determine that coefficient, that number 3, where do we get that 3 from? We basically kind of rewrite the equation that I showed in the previous page, and we say that coefficient is equal to the top of descent times 1,000 divided by the cruise altitude minus the pattern altitude, and we come up with the number 3. And now we can just substitute that 3 into the basic equation. And again, this basic equation works for descent rate of 500 feet per minute and a ground speed of 90 knots. But what if we use a different ground speed? Let's assume a descent rate of 500 feet per minute and a ground speed of 120 knots. Let's say we're a faster airplane with a cruising altitude again of 5,500 feet and a pattern altitude of 1,500 feet. First, we have to determine the time it will take to descend from a cruising altitude to the pattern altitude. 5,500 minus 1,500 equals 4,000. Again, 4,000 divided by 500 feet per minute is taking 8 minutes. Next, we need to convert that minutes to hours, and doing the math, it comes up to 0.133 hours. Next, we need to determine the horizontal distance traveled while descending from the cruise altitude to the pattern altitude. Using the equation, again, distance is equal to velocity times time. In this case, our distance, which again is our top of descent effectively, we are going to use a velocity or ground speed of 120 nautical miles per hour, times, again, that time of 0.1333 hours that we calculated just above, which equals 16 nautical miles. And so if we want to come up with a modified basic equation, we need to find the new coefficient. We just basically do some simple algebra and we determine the z, the coefficient. So we take z, the coefficient, is equal to the top of descent times 1,000 divided by the cruise altitude minus the pattern altitude, and we get 4 for that coefficient. So this yields the basic formula of top of descent is equal to 4 times the cruise altitude minus the pattern altitude divided by 1,000. Again, this formula, with using the 4 as a coefficient, is for 500 feet per minute descent rate and a ground speed of 120 knots. So you can come up using this basic math for any variation of feet per minute descent rate that you want or ground speed that you want. But in general, most of the time in GA for these smaller planes, Warriors, Piper Archers, Skyhawks and stuff, we're normally descending about 500 feet per minute with a ground speed of around 90 knots. So the basic equation of 3 times the pattern altitude, the cruise altitude minus the pattern altitude over 1,000 normally works. But if you have a faster plane or you want to descend steeper, you're going to have to do something like this as the math is shown here on this page. So that's it on how to determine top of descent. Very easy formula to use, and you can basically modify it to whatever ground speed that you may be wanting to travel at, or for what type of descent rate that you want to descend at. Anyways, hopefully you found this video helpful, and if you did, make sure you hit that like button and subscribe to the channel so you get notified on my next video.